Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 6.2, which is going to deal with angle, angle, side, triangle congruence. So today we're going to add in our fourth triangle congruence shortcut to the other three of side, angle, angle, and side, side, side. Now, if you do notice, we have skipped section 6.1, and that is by design, so it's not that you missed something. It's just that we decided to take section 6.1 out and just move on to 6.2. So for today, you only have one learning goal, and our learning goal for today is that you will be able to prove two triangles congruent using the angle, angle, side, or AAS theorem. So today we're going to determine whether or not triangles are congruent based off of having an angle, angle, and side. So what this looks like is if two angles in a non-included side of one triangle are congruent to the corresponding angles and non-included side of another triangle, then the triangles are congruent. So when we talked about angle, side, angle was the ASA. That was where you had to have two angles and the side in between. For angle, angle, side, we need to have two angles like such in the non-included side. So this one's talking about the non-included side. So that means I don't want to talk about this side right here because that would be ASA. So that means it just needs to be one of the other two sides. Doesn't have to be a particular one, it just has to be one of them. So let's go with the idea that this side needs to be congruent to this side. Now, one quick note, if it goes this one is congruent to this one and then this one to this one, it has to be this side to this side. It cannot be over here. The order has to match where it's angle 1 to angle 2 to the side, angle 1 to angle 2 to the side. You cannot do reverse or like a different set of sides. It has to be the same order to match it. So today, when you go through and identify if your triangles are congruent, again, you need to have two angles in a non-included side. Two angles in a non-included side. Key thing again is it has to be ordered. So angle 1, angle 2, side, angle 1, angle 2, side. That order has to match. Okay, so with that said, let's go ahead and jump into example 1, which is going to ask us to determine whether or not we can use angle, angle, side to prove the triangles are congruent, and then explain our reasoning. All right. So for example 1, part A, so we have triangles ABC and triangle DEF. We have to determine if we have enough information to prove these two triangles congruent. Well, first thing I know is that angle A is congruent to angle D, and just to kind of help keep order matching and make sure that they do match, okay, we're going to call this angle 1. So I have an angle 1. Next, because we need to know that two angles are congruent, so I know that angle B is congruent to angle E based off the two congruent marks. So this is my angle 2. And then lastly, they give me the side AC is congruent to the side DF. So I can say that AC is congruent to DF. So I now have a side. Now, if we go through and look at this, can I say that they are congruent based off angle, angle, side? I have two angles and I have a side. We just have to make sure that the order matches for both of them. So if I start with angle 2, so it's angle 2, angle 1, side, angle 2, angle 1, side. So it does match in terms of order. It doesn't have to be like I showed up above where it goes 1, 2 side. Okay, it can go 2, 1 side. So I can say that yes, these two triangles are congruent based off angle, angle, side. Okay, so continuing on, if we take a look at B, for part B, they tell me that this angle is congruent to this one, so that's my first angle. Next, they tell me that this side is congruent to this side. So I now have my side. If we look at anything else, okay, if we look at this triangle, they don't really tell us anything else in terms of angles. Okay, I don't know anything about these angles or these two, so I can't say anything for sure. I do know that these two sides are congruent because the reflexive property. So I do know that this side is congruent to this side. Okay, but I need to prove it based off angle, angle, side, not by using that. So my answer is going to be no. And something else I just want to identify because this is a good point to talk about it. You cannot use side-side angle. So side-side angle would look like this. If you reverse it, okay, it spells something else. The angle side-side, if you switch the order of this, you cannot use that, okay? Think about the reverse order of this. ASS is not an appropriate word to use in everyday life, and it does not work in math, okay? So anytime that you have the order of ASS or SSA, know that that does not work. Okay, we've talked about a lot of them so far in terms of SAS, ASS, or not ASS, ASA or SSS. Okay, know that SSA does not work. Okay, do not ever use SSA or ASS. It's not a triangle congruence statement. Okay, ones that do work are, as we talked about today, angle, angle, side, 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 angle, side, angle, and side, angle, side. These are the four that work. This is the one that does not work. Okay, so a slight caveat on that. So really today, all you need to know is if you can identify two angles and one side length, and if they match the same order, and it's not the included side. So let's continue on for parts C and D, so that way we can get a little more practice with this. All right, so if we take a look at C, I know that angle B is congruent to angle D because they're both right angles. So they're both 90 degrees. So that's my angle 1. I also know that angle C is congruent to angle F because they tell me with the one congruent mark. So that's my angle 2. And then they tell me that the side AC through one tick mark is congruent to the side EF. So, can I say that these two triangles are congruent based off AAS, or angle, angle, side? Well, this goes angle 1, angle 2, side. This one goes angle 1, angle 2, side. So it would be AAS because it goes 1, 2, side, 1, 2, side. So I can say yes, that they are congruent based off angle, angle, side. Okay, for part B, or not part B, sorry, part D, they tell me that angle C is congruent to angle E. So I have my first angle here. Next, I have angle B is congruent to angle D by the two congruent marks. So I have my second angle, and then they tell me that AC is congruent to DF. So I know this side is congruent to this side. So I now have my two angles in my one side. We just have to make sure the order matches. So for this one, it goes to one side, it goes 1 to side. So if you followed and if you caught it, this one went to one side, so it went 2, then 1. This one goes 1, then 2. Because the order is reversed, where this one goes 2, then 1, this one goes 1, then 2, then side, we cannot say that these two triangles are congruent based off angle, angle, side. So they're not congruent, so my answer is no, because the order does not match. Okay, that's why it's helpful to go through and indicate what angle it is with 1 and 2, so that way you can keep track of how it should go. So this one goes to one side, whereas this one goes 1 to side. All right, so with that said, there are two more that I would just kind of like to run through real quick and highlight for us. All right, so next we're going to take a look at examples E and F for today. For E, I know that this angle, so my first angle, matches this angle here. So I've got my angle 1s. Next, I know these two angles are congruent, so I have my angle 2s. Now, I have my two angles. I now have to identify if I know that a side length is congruent, and I do know that one is, using the reflexive property. So I know that this side is congruent to this side based off of reflexive property. So my order is 1 to side, 1 to side. So that means that these two triangles are congruent based off angle, angle, side. All right, last one for part F. So they tell me that angle G is congruent to angle J, so that's my first angle. The other thing they tell me is that the side GK is congruent to the side JK, so I now have my side. So I need to identify a second side, or not a second side, sorry, a second angle. So my second angle is actually going to come from right here. And recall, and I tell you it keeps popping up, two straight lines that cross, opposite angles are congruent, so they're vertical angles. So that means I have my second set of angles. So I now have my angles 1 and 1 because they told me, my side and my side, and I know these two angles are congruent because of vertical angles. So can I say that these two triangles are congruent based off angle, angle, side? Well, if I go through, okay, this goes angle 1 to the side to angle 2, know that I cannot jump around. So I cannot do 1, 2, side, so I couldn't do angle, angle, side. Okay, you cannot jump around open stuff. So the only way this is going to work is by angle, side, angle. So this does not work based off angle, angle, side. But angle, side, angle does work. So it's a no based off angle side, but it would work if we could use angle side angle. Okay, so that is it for example 1 on determining whether or not you can use angle side to prove the triangle's congruent. Remember, it's got to be two angles and a non-inclusive side. Okay, this one includes the side. Okay, a non-inclusive side would be either one of these sides, not this one. So that's why this is a no. This one is yes because two angles and a non-inclusive side, and the order does match. Okay, order has to match angle 1, angle 2 side, or angle 2, angle 1 side. All right, so with that said, let's go ahead and take a look at example 2. Now, example 2, much like all of our example 2s for module 5, is going to follow the same format here by asking us what additional information do we need to prove the triangle is congruent based off angle side. So, if we look at part A, they tell us that angle P is congruent to angle A. So I have my first angle, and then they also tell me that the side RQ is congruent to the side BC. So I have my angle 1s and my side lengths. If I'm trying to prove it based off angle side, that means I need to know an additional angle. Okay, I already have one angle, so that means I need to know a second set of angles. Now, when you are going through and choosing your angle, you just have to be careful that you do not include the side. Now, because angle P and angle A aren't at all involved with this side length, that means whichever angle I choose, it's not going to be an issue. So I could realistically say that I need to know that angle R is congruent to angle B, but I could also say that angle Q could be congruent to angle C. Either way, that is going to result in me having an angle side or an angle side. So either of these work for this because they do not include the side. You just have to be careful to not include the side, which I will talk about in part B. Okay, so with that said, let's take a look at part B. So they tell me that angle P is congruent to angle G. So I have my angle 1. And then I know that angle Q is congruent to angle H, because they told me. So I have my angle 2. So I already have my two angles, so I need my additional side. The key is that it needs to be a non-included side. So the included side would be this RQ and HG. So I need to choose a side that is not this side. So that means I could go with RQ or RP, just like I could go with IH or IG. You just cannot use the included side to say angle side. So I have two options for this one as well. I can say RQ is congruent to IH, or I can say that RP is congruent to IG. Both of those would be an appropriate answer for part B. All right, so that is it for example 2. Now, on the back side, for example 3, we have a litany of proofs, or just two, really. that they want us to complete for example 3. So we're back into the 2-column proof game, and I just really want to walk us through it, and I highly suggest when you go through the homework, you either have the completed notes pulled up so that way you can reference the proofs, or you have the video up as a reference. Okay, the notes, the completed notes, and the video will be extremely helpful for you when you get to the proofs on the homework. Just something to be aware of. Alright, for the first proof, okay, they tell us given AC is congruent to EC. So what they're saying is that this side is congruent to this side. Okay, and my first statement here is that AC is congruent to EC, and because they told me that, we can say given. Alright, the next part is they state that M is parallel to N. So that's what that means right there, is that M is parallel to N. So that means this line is parallel to this line. And I know that because that is given. Okay, so let's then go through and try to figure out my statements for the next part. So they say that angle D is congruent to angle B. So how do I know this angle is congruent to that angle? So how do I know these two angles are congruent to each other? Well, it might take you a second, but I have two parallel lines cut by a transversal. These two angles are in between, so they're inside the parallel lines, and they're on alternate or opposite sides of the transversal. So that means based off alternate interior angles, that those two angles are congruent to each other. We follow the next idea, so we're talking about angles A and E. So we have angles A and E. Again, I have my two parallel lines cut by a transversal. A and E are inside the parallel lines, so they're interior. They're on alternate or opposite sides of the transversal. Therefore, again, my reason would be alternate interior angles. So, Module 4 does not fully go away. Alright, and then lastly we have triangle ABC congruent to triangle EDC. Well, I've already gone through and stated that I have two angles and a side, so we just have to make sure that the order matches. So I have my first angle, my second one inside, my first angle, second one inside. So that does work. So I can say based off angle, side, that triangle ABC is congruent to triangle EDC. So these two triangles are congruent to each other. And that is our first proof for today. Alright, let's take a look at our second one. Alright, for our second proof, okay, they tell me that CB is parallel to ED and AB is parallel to CD. So they're saying that this side is parallel to this side. They're also telling me that this side is parallel to this side. So odds are we're going to have some sort of angle relationship, whether alternate interior, corresponding, same side interior. And then they also tell me that CB is congruent to ED. So that means I know this side is congruent to this side. So my first statements are that the two lines are parallel, and I know that because it's been given to me. Then they also state that CB is congruent to ED. That has also been given to me. And now is where we get into the info that's not given. So, First thing is they state that angle CAB, so CAB is going to be this angle right here, is congruent to ECD, which is going to be this angle right here. So how do I know that those two angles are congruent? Well, if I have my two parallel lines cut by my transversal, okay, they are on the same side of the transversal, on the same spot of the parallel lines. So that means that these are corresponding angles. And corresponding angles are congruent to each other. Alright, and then they tell me that ACB, so we're talking this angle right here, is congruent to CED, so this angle right here. Again, if we think about our two parallel lines cut by a transversal, okay, same side of the transversal, same spot of the parallel lines. Therefore, again, I know that they are congruent based off corresponding angles. Alright, and then my last part is going through and stating that these two triangles are congruent. So how can I say that these two triangles are congruent? Well, if we're talking about angle, angle, side today, I have angle 1, angle 2, side, angle 1, angle 2, side. So I can say, based off angle, angle, side, that these two triangles are congruent. And that is example 3 for today. Alright, now, up to this point, that's kind of been usually our stopping point for Module 5, but today we are going to add in example 4, where we're going to continue using the angle, angle, side theorem, but in this case we're going to prove the triangles are congruent based off of our graphs. Now, our graphs are a little bit harder to see, at least on this, because my copy didn't turn out real too well with the grid lines. So I'm going to go ahead and pull up my completed notes and explain what I did. So the grid lines show up a little bit better here. So for example 4, they want us to state based off angle, angle, side that the triangles are congruent. Well, the first thing is they tell me that angle A is congruent to angle D. So that means I know A is congruent to D, and that's because that's given. Now, if I'm wanting to use angle, angle, side, I need to have another angle. Now, I could potentially find out what the measure of angle C is compared to F, but I don't know. But I do know, because these two lines are perpendicular to each other, that angles B and E are right angles. So I know that B and E are congruent because they're right angles, because I have my corner right there. So because I have my corner, these two lines are perpendicular. One's vertical, one's horizontal. That means they form a right angle. And then I lastly said that BC is equal to EF because I needed a non-included side. So I cannot use AB, but I can use BC, and I just counted by doing 1, 2, 3, just like this side is 1, 2, 3. Technical way to do that would be to use the distance formula. I just did it by counting. So I could then say based off angle, angle, side that these two triangles are congruent. Now, if we kept the same idea for part B, so they tell me that angles P and Z, so P and Z are congruent, and that Q and X are congruent, so we have Q and X. So I have my two angles because they gave me them, and then I just need to say an additional side, the non-included side, so I can't do anything with XZ or PQ. I'm going to use the one that's straight up and down, just like I used the one that's straight across and straight up and down here, straight lines, and I know these are all straight lines, but either vertical or horizontal lines are great to use for this. If I used ZY and OP, I would have to use the distance formula, that square root of x2 minus x1 squared plus y2 minus y1 squared. None of us like using that. Counting is the best and easiest way. So I'm just going to use the straight up and down side and the straight across. So my vertical side would be 1, 2, 3, 4, 5, 6, 7. And over here it's 1, 2, 3, 4, 5, 6, 7. So because these both, using counting, they both have a length of 7 units, it means they are equal to each other. Thus, using angle side, I can say that those two triangles are congruent. All right, so that is it for section 6.2, dealing with angle, side. So we have now successfully, and I'm going to go through and write down, we have successfully talked about angle, side, side, angle, side, side, and angle, side. So we have successfully talked about 4 different triangle congruence statements. So we found 4 different shortcuts. Instead of going through and finding that all 3 sides and all 3 angles are congruent, we can use any of these 3 shortcuts. Tomorrow, or the next day, we're going to talk about our final shortcut, which is going to be referred to as HL, or hypotenuse leg. So we're going to talk about right triangles tomorrow. And just remember, we cannot use side angle. Okay, that's the only one we can not use, because if we reverse the order, okay, it spells a certain word. Just like in real life, we cannot use that in math. So these are the 5 that we will be ending up using after we talk about HL, or hypotenuse leg, tomorrow. This is the one that you cannot use. But otherwise, that is it for today on section 5.4 for angle, side. Sorry, section 6.2, not 5.4, on angle, side. So that is it for my lesson and my video today. As always, if you have any questions, just let me know next time you see me, or send me an email, and I'll be more than happy to help however I can. So again, I highly recommend that you have your completed notes out as you work through the homework, as they will be really helpful to you. But otherwise, that is it for today. Thank you for listening, and have a great day.